This time we've been given a farming problem that we're going to put into terms of a linear programming problem. So you need to read through the question carefully, define variables, state the objective function, and state the constraint inequalities. So have a read and I will get started. Okay, so we've taken G, S and B to be the areas in metres squared where the farmland is planted in garlic, which is here, silver beet or beetroot, over the course of the year. And for our objective function, we're letting Z be the total worth of the crops produced on the farm over the year. It's not surprising that for a farming problem, our objective is to maximise the profit. And that's given in the clue here. So now it's easy to write the objective function. We say we want to maximise Z, which is equal to 100 times G plus 40 times S, a silver beet, plus 60 times B for beetroot. And then this is subject to constraints, so we say subject to. Now, naturally, we have two constraints here, but before we go for these, there's one common sense one. The farm has a finite amount of land, and that's 4,000 square metres. So if we add up G plus S plus B, which is the area we're planting with our crops, that will be less than or equal to 4,000. Now we can tackle this one. So the first one is to do labour. Planting a square metre of each crop requires a certain amount of labour. A metre of garlic requires 2 hours, so 2G, plus silver beet requires half an hour, so half S, and beetroot requires 1 hour, so plus B. And that will be less than or equal to 3,500. Then any one crop shouldn't take up more than half of the farm. So X1, X2 and X3 will each individually be less than 2,000, which is half of our total farmland. And then we're not planting negative crops. So X1, X2 and X3 will all be greater than or equal to 0. And we're done.